Polar bears and polar cubs, it's time to challenge those brains with the Mole Day challenge problems. Now, you might be going, Mr. Day, Kevin's already kind of challenged my brains enough. Why do we need to do challenge problems? Well, we do challenge problems as a way to celebrate the mole because it brings together two things that we've learned before. So it brings in molar conversions from chapter 3. It also brings in a little bit of the dimensional analysis from chapter 2 that drove you guys nuts. But if you take these notes and you keep your worksheet, Mole Day challenge problems on Friday should be no issue. All right, here we go. So the question reads, if I have a mole of cars and I stack them end to end, we want to know, would it reach back and forth across the United States how many times? Okay, it gives us the measurement of one car as 350.2 centimeters, and then it tells us how far across the United States is. So how do we do it? We're going to start with one mole of cars over 1. Well, that's great and all, but we need to know how many cars are actually in that mole. Well, there are 6.022 times 10 to the 23rd cars in one mole of cars. Well, now that I have the number of cars, I would really like to get into length. That's probably why they told me the length of a car. Well, that means I get 350.2 centimeters per one car. Well, now that I'm in centimeters, we want to know how many times it can go across the United States and back. Well, that was given to me in miles. So we need to get out of centimeters into miles. Well, I know, based off the back of the periodic table, that we want to do that at kilometers. So 1 kilometer is equal to 10 to the 5th centimeters. How did I get 10 to the 5th, you might ask? Well, I got 10 to the 5th because between centi, which is 10 to the negative 2nd, and kilometers, which is 10 to the positive 3rd, it is 5. The difference is 5. Also on the back of the periodic table is 1 mile equaling 1.61 kilometer. Now, I've said this before. I said it back in chapter 2. You must use the conversion factors from the back of the periodic table in order to get the correct answers. You will not get the correct answers on the Mole Day challenge problems if you are trying to use some kind of conversions that you find on the internet. And that would help. All right. Just going to group these together because we need some space. Shrink it down a little bit. So now we're in miles. Well, one there is 2,802 miles. But we want to go there and back, or back and forth. So that means that it is one round trip, okay, per 2 theres, because you would agree that a there and a back is really 2 theres. All right, that's our work. I know it looks like a lot. So what we're going to do is we're going to take tops, we're going to multiply them all together, and then we're going to take the bottoms, multiply them together, and do one division problem. This is a huge step. Do the intermediate step. So on the tops, it is only 6.022 times 10 to the 23rd and 350.2. So when I multiply those together, I'm going to go to 4 or 5 sig figs because I know that at the end, I'm going to round them all down to 3. So I have 2.1089 times 10 to the 26th. On the bottom, you have 10 to the 5th, 1.61, 2802, and 2. So when you multiply those together, you're going to get 9.02 2 times 10 to the 8th. When we divide the fronts, we're going to get 0.2337 times 10. Now, the exponent here, you subtract 26 minus 8, giving you 18. Now we need to get our final answer. In order to get our final answer, we need to put it in scientific notation and round to 3 sig figs. That's going to give us 2.34 times 10 to the 17th. And that would be round trips or there and backs. All right, that's one style of problems. This would be a distance style of problems. We're going to try another one. Question number 2 is another style of problem. This is a volume style. So you have a mole of BBs, and we would like to fill the lake across the street in Jackson Park. The volume of the BBs we have is 6.25 milliliters per 35 BBs. And then the volume of the lake across the street is 245 meters cubed. So first thing, again, every single one, we're starting with 1 mole. This is of BBs over 1 times, again, times Avogadro's number. So the first 2 steps should look the same just about for everyone. Now that we're in the number of BBs, now we can use this kind of conversion factor to go. So we want to get into volume. So we're going to put 6.25 milliliters up top. We're going to put 30 BBs on the bottom. So again, that they cancel out. Now that we're in milliliters, we need to get to meters cubed. So in order to do that, we need to use the 1 centimeter cubed per 1 milliliter. We're going to go ahead and group these together. Because we have some more. So now that I'm in centimeters cubed, I need to go to meters cubed. So I need meters up top 3 times. Centimeters down at the bottom 3 times. Meters is going to get the 1. It's bigger. There are 100 centimeters in a meter, so that is 10 to the second. And finally, it is 1 fill of the lake for every 245 meters cubed. There's our steps for a volume. So what we're going to do is, again, I cannot stress this enough, tops, bottoms, and then do one division problem. So on the tops, you have 6.022 times 10 to the 23rd. You also have 6.25 milliliters. So when you multiply those together, you're going to get 3.764 times 10 to the 24th. For the bottom, you have 30 and 10 to the 6th. Because 2 plus 2 plus 2 is 6, and 245. That gives you a number of 7.350 times 10 to the 9th. Again, we're going to divide the front numbers, and we're going to get 0.5121 times 10. Now with this, we're going to subtract. 24 minus 9 gives us 15. Now we need to put it in proper scientific notation and round to 3 sig figs. So we're going to move this back 1, giving us 5.12 times 10 to the... Now, if you move it back 1, you subtract, which makes 15 into 14, and this would be fills. Volume seems to be the one that gives you guys the most trouble, and that is because, 1, you have volume to the number of items. Also, a lot of times you have to take it out of a singular volume unit and put it into a cubed unit. So you have to do everything 3 times. All right, that was question number 2. Let's go to question number 3. Question number 3 is the third and final type of mole day problems, and that would be a mole of stuffed moles would equal the mass of the Earth how many times? So if one stuffed mole equals 27.65 ounces and the mass of the Earth is 5.972 times 10 to the 24th kilograms, given this little conversion right here, how many times could we fill the Earth if we had a mole of stuffed moles? So we're going to start, and we have 1 mole of stuffed moles, that's SM over 1, times, we need to get to Avogadro's number, because that's how many stuffed moles are in a mole of them. Now that we're in stuffed moles, we got a lot of stuffed moles, we need to get into some kind of unit for mass. So the first thing that we're going to do is we know that 27.65 ounces is how many, what the mass of 1 stuffed mole. The next question that we're going to do is we need to get out of ounces, we need to get to grams, because we're going to get into kilograms. So the first thing that we know is that 1 ounce is bigger, and it is 28.3 grams. Now we can go directly to kilograms. So it is 1 kilogram is equal to 1,000 grams. Now that we're in kilograms, we can use our factor of the mass of the Earth, and we can do 1 Earth is equal to 5.972 times 10 to the 24th kilograms. And there's our work. So again, we're going to set up this intermediate factor. So you take the tops, you multiply them together. Take 6.022 times 10 to the 23rd times 27.65 times 28.3, and you should get a number of 4.712 times 10 to the 26th. On the bottoms, you got 10 to the 3rd and our mass of the Earth. So we're just going to add that 3 to the exponent. So you get 5.972 times 10 to the 27th. Again, we're going to divide the fronts and then subtract exponents. So when you divide the fronts, you're going to get 0.7890 times 10 to the negative first. So last steps is round to 3 sig figs and put it in proper scientific notation. So we're going to move this back 1, giving us 7.89 times 10 to the negative second, and that would be Earths. So here's what we want to do. I got one more sample problem in here. It is of one of the 3 that you've done. What I would like you to do is go ahead and give it a shot. Okay, I'm going to have you pause it while you're working on it. And then when you're done, go ahead and unpause it and see how well you did. Okay, here's your question. Go ahead and pause it and unpause it when you're completed. And after 3 seconds, after the countdown, it should show you the work and the answer. 3, 2, and 1. All right, we're going to start with our given over 1. 1 mole of pasta over 1 times Avogadro's number per 1 mole of pasta. That's the number of pieces that we have. Again, this one, we need the pieces down at the bottom. And that would be 125.25 milliliters. Now we're going to go to centimeters cubed out of milliliters. And then we need to get from centimeters cubed to kilometers. So kilometers cubed, 10 to the 5th centimeters. We're going to do that 3 times. Now that we have that done 3 times, what we need to do is then actually do it again 3 times, but this time we're going to miles. Okay, so it will be 1 mile over 1.61 kilometers. That's 3 times. And then finally, then we can do the fills of Lake Erie. So 1 fill is equal to 115.2 miles cubed. Do your intermediate step. 7.539 times 10 to the 25th and 1.683 times 10 to the 20th. When you divide, you should get a final answer of 4.48 times 10 to the 5th fills of Lake Erie. All right, I hope you've got it down. Go ahead and keep these notes because guess what? You're going to be able to use them on your Mole Day Challenge problems. Keep in mind, you have to get 3 of the 5 questions on the Mole Day Challenge problems. Anything more than that is bonus. All right, let me know if you have any questions.